Lesson 9, Which Variable to Solve For, Part 2. Learning target, I can write an equation to describe a situation that involves multiple quantities whose values are not known, and then solve the equation for a particular variable. Solving for an equation is an efficient way to find out the values that meet the constraints in a situation. It can be helpful to solve for different variables depending on what we know and what we're trying to find out. Let's look at an example. Suppose you're organizing a party and have a budget of $B for appetizers. You plan to order V vegetarian spring rolls at 75 cents each and S shrimp rolls at 95 cents each. The equation 0 and 75/100 V plus 0 and 95/100 S equals B represents the constraints. Let's first examine when our original equation 0 and 75/100 V plus 0 and 95/100 S equals B is the most helpful. This equation is most helpful when we want to find out how much different combinations of rolls would cost. Now let's look at the equation that's solved for V. Here we have V equals B minus 0 and 95/100 S divided by 0 and 75/100. When is this most helpful? This equation is most useful when we know the budget and we want to find out how many vegetarian rolls we could get if we ordered different numbers of shrimp rolls. Lastly, let's look at the equation that's solved for S. Here we have S equals B minus 0 and 75/100 V divided by 0 and 95/100. When is this most useful? This equation is most helpful when we know the budget and want to find out how many shrimp rolls we could get if we ordered different numbers of vegetarian rolls. Let's look at another example to practice solving for different variables, this time regarding elevator boxes. An elevator has a capacity of 3,000 pounds and is being loaded with boxes of two sizes, small and large. A small box weighs 60 pounds, while a large box weighs 150 pounds. Let X be the number of small boxes. Let Y be the number of large boxes. The equation 60X plus 150Y equals 3,000 represents the combination of small and large boxes that fill the elevator to capacity. Now we can use the equation from the previous slide to answer a question about elevator boxes. If there are 10 large boxes already, how many small boxes can we load onto the elevator so that it fills to capacity? We can use substitution 10 for Y and perform acceptable moves to solve for the equation. Or, a more efficient way would be to first solve for X. Our first step to solve for X would be to subtract 150Y from both sides. Our last step to solve for X would be to divide both sides by 60. Remember that a fraction is another way to express division. Our equation now is X equals 3,000 minus 150Y divided by 60. This equation allows us to easily find the number of small boxes that can be loaded, X, by substituting any number in for the large boxes, Y. To find the number of small boxes, if there are 10 large boxes, we need to substitute 10 in for Y. When we simplify the right side, we find that we should load 25 small boxes onto the elevator. Now we can use the equation from the previous slide to answer a question about the elevator boxes. If there are 42 small boxes already, how many large boxes can we load onto the elevator so that it fills to capacity? We can substitute 42 in for X and perform acceptable moves to solve for the equation. Or, a more efficient way would be to first solve for Y. Our first step for solving for Y would be to subtract 60 from both sides. Our next step would be to divide both sides by 150, so that our equation now becomes Y equals 3,000 minus 60X divided by 150. This equation allows us to easily find the number of large boxes that can be loaded, Y, by substituting any number of small boxes in for X. To find the number of large boxes, if there are 42 small boxes, we would need to substitute 42 in for X. When we simplify this, we find that Y is approximately 3 2/10. We can't have a decimal of a box, so we would say we should load 3 large boxes.